Hello everyone, I am Yogendra Singh. I belong to Baroda in Rajasthan. I completed my graduation from University of Delhi and currently I am pursuing Master in Mathematics from IIT Jodhpur. Today I will explain concept of limit. The concept of limit is foundation of calculus. So in this video first we see definition of limit, after that we see existence of limit, and after that we see two examples where first we show the limit is exist and another example show that limit does not exist. So let's start. So first f of x is real valued function. Real valued function. और जो c is any real number. C is any real number. Okay. When we say limit exists, limit x extends to c. Limit x extends to c. Function f of x is equal to L. When we say limit exists, limit x tends to c. F of x is equal to L. L is equal to limit of the function f of x. It means that when we approaches towards the c, the function value is also approach towards the limit L. Okay, we can visualize through graph. This is our x-axis and this is our y-axis. Okay, let's take random graph. This is f of x. Okay, we take a point C on x-axis. This is any point on arbitrary point on x-axis. The value of limit at point C is L. Basically, when we check limit, we see neighborhood points of C. We see neighborhood of point of C. We can easily see that when we move close to C, the function value f of x is also close to L. Then we say the limit of a function is L. We clearly see that there are only two ways to approach to C. One is from left side and one is from right side. One is from right side and one is from left side. Okay? So when we calculate limit from right side, we say limit x extends to C positive. This means that we are approaching C towards right side f of x. It is called right hand limit. When we approach limit x tends to C minus, in this case when we approach C towards left side, then we say limit x tends to C minus f of x. This is called left hand limit. If both limit are equal, then we say limit is exist. If both limit are equal, then we say limit is exist. Also one condition is added, both limits should be finite. Both limit should be finite. If they are not finite, does not exist limit. Okay, this is the main concept of limit. Okay, now we see one example where limit is exist. Okay, so first we take function f of x is equal to x plus 2. X belongs to R. We take a simple function, linear function, f of x is equal to x plus 2 or x belongs to R. We check limit at x is equal to 0. The function limit is exist or not. So first we see graph of this function. This is the graph of function f of x plus 2. Okay, this is the x-axis, this is f of x. This is the 0, this is 1, or this is 2. Okay, we have to check limit at x is equal to 0 on this point. So in this way we have two ways to check limit. One is from right side and one is from left side. So first we see from left side. When we move towards the 0 from left side, the function is also approaching to value 2. When we move from left side, the function value is from left side is approaching 2. Okay, we can also in another visualize from right side. We take some small value close to 0. We take value 0.1. X is equal to 0.1. We take x is equal to 0.1. So then f of x is equal to, we simply put value 0.1 in this equation, we get 2.1. Then we put x is equal to 0.01. Then f of x is equal to 2.01. When we put x is equal to 0.01, f of x is equal to 2.001. So we clearly see that when x approaches to 0, the function value is also approaches to 2. This is called limit, and we calculate from right side. So we get right hand limit. So limit x extends to 0 positive x plus 2. Function क्या है? X plus 2. What we calculate is 2. Simply we put or substitute value 0 plus 2. Because we approaching 0 2, so 0 plus 2 is equal to 2. We also calculate from left side. Left side we approach 0 to left side. So 0 closest value from left side is negative. So x we take 0 minus 0.1. Then f of x is equal to, when simply we put in this value in this function, we get 1.9. If x is equal to minus 0.01, then f of x is equal to 1.99, and simply 0.001, then f of x is equal to 1.99. In this case we also see that when x extends to 0, in this case x is small and close to 0, so we find the value f of x is equal to 2. This is the nearest value of 2. Or when we also close to 0.999 come, so we say that limit x extends to 0 minus f of x plus 2, 0 plus 2 is equal to 0. In this case, this is called right hand limit, and this is called left hand limit. In the case RHL equal to LHL, so we say limit is exists. Limit is exists. Okay. So now we see another example where limit does not exist. The example is, we make f of x is equal to x square plus 2 when x is greater than 0, x square plus 1 when x is less than 0, or not defined when x is equal to 0. We have to check limit at x is equal to 0. In this case, we clearly see that the function at x is equal to 0 is not defined, but 0 is not point of the domain. Okay. Then we also calculate the limit at that point, because limit does not define at that point. Limit always define nearest the point at which we calculate. So we calculate the limit at x is equal to 0. So first we draw the graph of this function. The graph of function is look like this. this is 2, this is 1, this is 0, this is x axis, this is f of x, or this is function is f of x is equal to, this is function f of x. Okay, we have to check limit at x is equal to 0, means at this point we have two way to approach. One is from right side, one is from left side. Okay, when we move x tends to 0 from right side, the function value is attained is 2. When we move x tends to 0, the function value attains 1. So we say that limit x tends to 0 minus the function f of x is equal to limit x tends to 0 minus function, which function we use, x is less than 0, which function we use, x square plus 1. So simply we put the value 0 plus 1 is equal to 0. Okay, and we also find from right side. So limit x tends to 0 positive f of x, then limit x tends to 0 positive, which function I use, x is greater than 0, then function we use x square plus 2, in which case 0 plus 2 is equal to 2. This is called HL limit, or this is called RHL limit. In this case, LHL does not equal to RHL. In this case, RHL does not equal to RHL. So we say limit does not exist. Limit does not exist. Okay, this is the example where limit does not exist. So in this video we learn foundation of limits and see example when limit does not exist and limit exists. Thank you for watching this video.